Hello everybody and welcome back to the Design Pattern series. Today I will talk about the aggregator pattern, which is a design approach towards simplifying the complexities of interacting with a microservices ecosystem. Just like in the API Gateway pattern video, we will explore the aggregator pattern, look at a demo, and check why and how we can implement this pattern in your microservices. Now think of aggregator pattern as a waiter. When a client makes a request, instead of reaching out to every microservice individually, it goes to the aggregator. The aggregator then communicates with all the necessary microservices, gathers response, combines them, and sends back a single organized unified response to the client. And just like a middleman, the process functions in a very streamlined way for everybody involved. The responsibilities of routing requests to the different microservices, aggregating results, ensuring that the clients get a very cohesive experience happens without the need of managing multiple points of contact. This pattern is very useful when your client app needs to make multiple calls to different backend systems to perform an operation. The microservices architecture structures an application as a set of loosely coupled microservices. However, when we are building a large and complex application using microservices, we often require a combined result of multiple microservices to be shown on an application page. Let's look at an online shopping store where the user views a product and the app needs to display various details about the product, such as the product name, description, price, available quantity, and possibly reviews and recommendations about the product. These details are often stored in different microservices, each responsible for a specific aspect of the product information. Now, for the application to show this page, it has to call all these different services and get data from them to show on the page. Now the client app has to make multiple network calls to get data from each service. In addition to that, if your microservices are located and hosted in different geographies, it sort of adds to the latency. All aggregation logic for the gathered data needs to be handled in the client app. This sort of adds to more complexity and can lead to inconsistent user experience. So what do we do to prevent these challenges? We use the aggregator service, which is a microservice itself that receives single request from a client app and calls all the different microservices involved and gets the data, combines it, and processes the logic. It sends a unified singular response in the form of a data transfer object to the client app, so it can consume and bind the product details page. The aggregator will abstract all the backend processing and send a formatted output to the front-end application. If there are future enhancements or additional features added to services, they get handled by the centrally coordinated and the aggregation by this service. Now in this example, let's check out what is happening on the product details page scenario again. Product catalog service retrieves the name, the product name, price, description, and the inventory service fetches the information about the quantity that is available in stock. The shipping service maybe provides discounts and pricing, and user review service gives ratings and user reviews for the product. When a customer accesses their own dashboard or order history page, then the client app sends a request to the aggregator service. The aggregator service then makes all these internal requests to the relevant microservices. It queries the product catalog service to fetch the product details, gets the inventory from its own microservice, and interacts with users to obtain the reviews and ratings for a particular product. The aggregator service now combines the data received from these microservices into a single unified response. For example, it gets the product details like name, images, and description. Then it gets the inventory, the current stock available, and the reviews, user reviews for the product, and the pricing when it applies discounts and derives the final price. Finally, the aggregator service responds to the client with this aggregated data. You see the benefits we are getting here? It ensures that the systems can handle all the increased load and maintain performance with a growing user base. Easy to understand and implement. The aggregator pattern is easy to implement and it simplifies the development process by providing a unified view of the data. The aggregator pattern offers flexibility in defining the signature of the internal services. It allows each microservice to focus on its specific domain while the aggregator handles data and combination of data. It's easy to maintain and adapt to changes, and this centralization also streamlines the client code and reduces the complexity overall of the application. Now let's look at the same aggregator service implemented in the real sense. I'm in Visual Studio and this project shows you how to build an aggregator service for your microservices with an example of product catalog service, an inventory service, and a user review service for a particular product. Now, I have a .NET Core solution and these three API service projects, the product catalog API, inventory, and the review service API. Now let's look at these in detail. Product Catalog API has a product entity which is represented by properties like product name, product ID, price, product description. The user review service has a review entity which is represented by product ID, username, content, and rating. The inventory service API has an inventory item entity which is represented by product ID and quantity in stock. Each inventory item represents a product in our inventory. Now, every API service project will have an entity and some sample data that is seeded into the system to represent that entity. So, for example, in this inventory service, we have initialized a list of inventory items. The list contains some initial seed data for items with their IDs, product ID, and quantity in stock. Each inventory item is a product in our inventory, and in these services, I have used the sample values to seed the data, but you can always use mock or faker libraries to seed the sample data. The app.mapGet method here, we are defining a route for handling the HTTP GET request to retrieve the inventory data. The route is inventory service /API/inventory. The Lambda function here is the handler for the route. It takes an optional filter parameter and allows to filter the inventory and product ID. If there is no filter provided or if the filter is empty, it returns all inventory items. Otherwise, it filters the inventory items based on whether the product ID contains the filter or not. The second app.mapGet method defines another route for handling GET requests to retrieve the inventory data by a specific ID. The route pattern is inventory service /API/inventory, where ID is the placeholder for that specific inventory item ID. The Lambda function is the handler for this route. It takes the ID parameter from the URL and searches for the inventory items. If the item is found, it returns the results.OK. Otherwise, it returns for not found response. The use HTTPS redirection, of course, redirects HTTP request to HTTPS. That is the security best practice. Now we have the aggregator service, which could be a separate microservice. Its job is to receive the request on all the required API services, gather responses, and process them into a single response DTO and send it to the calling service or the front-end application. So let's take a look at the aggregator service. In the aggregator service, the product DTO is a class that is defined as a data transfer object that represents a product. So you can see that it includes properties such as name, price, description, reviews, and inventory status. Now you can see several DTO classes in the aggregator service project. Let me collapse this. You have the review DTO class, the product DTO, and the inventory status DTO. Now, having separate DTO classes in the aggregator service project allows us to customize the data structure and include only the relevant and necessary information from each individual API service. It will also help to minimize the amount of data transferred between the services and also helps with the performance of the application. We are also providing a layer of abstraction between the aggregator service and the individual APIs, so that if the structure and properties of the entities in the individual services change, it won't directly impact the aggregator service, which can continue to work with its own defined DTO. So the aggregator service acts as a central point and it combines the data from all the different multiple services. Let's look at how the services and the data from individual APIs is combined. So here I have defined an aggregate service controller. The get method will fetches data from different defined services. So we have private methods which return data from the product catalog service, from the review service, and from the inventory service. So these methods are defined to make HTTP GET requests from the different microservices. Once all the tasks are complete, it aggregates the response into a product DTO object combining data from the product catalog, the review, and the inventory service. And finally, it returns an HTTP response with status code 200 OK and the aggregated product DTO object. So this is how the data from different API services is collated and returned in the form of product DTO to the front-end application. So aggregator service acts like a single point of access which can fetch you all the data for the front-end system. Now let's run the project. I have configured the solution to start all the individual API services and the aggregator service project when I run the solution. So here you can see the product catalog API. Similarly, you have the inventory service API and the review service API. And there is the aggregator service. So let's test out the individual API services in Swagger first. If you look at the inventory service API, you have the get method and the get method with a specific ID. So let's test this out. Let's test it with the product ID of 2. And it returns you the product ID B234 and the quantity in stock. Let's look at the review service. Let's get all the reviews for all the products. As you can see, it returns all the user reviews for the different products that are already seeded in the system. Now let's look at the aggregator service. Let's pass it a product ID. Right. And you get all the necessary collated data for the product ID 1. Returns the product details, the price description, all the user reviews for this product, and the inventory status with the quantity in stock. If you open Postman and run the same aggregator service API, you'll get the same data for the product. In this way, this aggregator service is a single point of access to get all data together for a front-end application. Integrating with ABP Commercial. In an ABP Commercial microservices project, Integrating an aggregator service follows a similar pattern as above. Let's look at general guide on how to implement an aggregator service within an ABP microservices project. Add a new application service. Within your ABP solution, add a new application service that will serve as your aggregator service. This service will contain methods to aggregate data from other microservices. Define DTOs. Define data transfer objects that represent the aggregated data structures. These DTOs will be used to transfer data between your aggregator service and the front-end applications. Implement aggregation logic. Implement the aggregation logic within your aggregator service, and this logic will make HTTP requests to the various microservices, aggregate the data, and construct the DTOs. Use HTTP client or ABP's remote service proxies. Use the HTTP client to make HTTP requests to the microservices from your aggregator service. If you don't want that, then alternatively, if your microservices are built using ABP, you can use ABP's remote service proxies for type-safe remote procedure calls. Handle authentication and authorization. Ensure that your aggregator service handles authentication and authorization appropriately when making requests to other microservices. You might need to pass along the authentication token or implement other authentication mechanism. Expose aggregator service endpoint. Expose an HTTP endpoint in your aggregator service application to serve as the entry point for front-end applications to consume the aggregated data. Front-end integration. In your front-end applications, that is the Angular, React or Blazor, make HTTP requests to the aggregator service endpoint to fetch aggregated data. Process the data received and update the UI accordingly. By following these steps, you can integrate an aggregator service into your ABP commercial microservices project. In this video, we have seen that in a .NET microservices setup, the aggregator pattern simplifies the front-end development and it improves the performance and makes the application more secure and the user experience more consistent. So in general, it helps to run a more user-friendly front-end application. It can handle lots of users and data without breaking. So we discussed implementation of aggregator pattern in a .NET Core application as well as in the ABP commercial microservices application. In our next video, we will discuss about the chain of responsibility pattern. So stay with us.